Okay, so 5.2 right triangle trigonometry. Sohcahtoa, everybody knows that stands, hopefully everybody knows. That's sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you want to know the ratio for sine, cosine, and tangent, we use Sohcahtoa, or you can memorize it a different way. So if I have a triangle that looks like this, and I'll call this A, B, and C, then the sine of theta is the opposite over the hypotenuse. So from theta here, the opposite is what letter, A, B, or C? Everybody see that it's B? Okay, so opposite go across, that's B, over the hypotenuse. The hypotenuse is always across from the 90-degree angle. It's always the longest side of a right triangle, so B over C. So sine of theta is B over C. The cosine of theta is adjacent. If you have two houses adjacent to each other, what does that mean? Right next door. Good. So right next door to theta is A and C, but well, C is the hypotenuse, so it must be A. So A over C, that's your cosine, and tangent is opposite over adjacent. Opposite over adjacent. B over A. Okay, those are your three basic trig functions. There are three more. If I take the reciprocal of sine, that is the cosecant of theta. And we know less about cosecant, but really it's just the reciprocal of sine, so it's C over B. The secant of theta and the cotangent of theta is the reciprocal of tangent, that would be A over B. So you can use Sohcahtoa to find sine, cosine, tangent, but you're going to have to remember that the cosecant and sine are reciprocals. The secant and cosine are reciprocals, and cotangent and tangent are reciprocals. I don't say opposite. Opposite in math means the opposite sign. So sine and theta and cosecant are not opposites. And they're not inverses, they're reciprocals of each other. Yeah?
I just have a question. When we're writing like sine, cosine, tangent, and those, do we have to put theta after the
Yep.
Okay.
Yes, good question. And that's a lot of people don't do that, but yeah, you're supposed to put the angle. Okay, so if I wanted to, let's say I have an example. We have a triangle that is, let's say this is 25 and this is 7. And I want you to find all 6 trig functions of this triangle for theta right there. So I want you to find sine of theta, cosine of theta, tangent theta, cosecant theta, secant theta, and cotangent theta. See if you can do that. Just to make sure we're on the right track, what's the first thing you did? Pythagorean theorem. You have to find the third side. Very good. So you have to find the third side right here using the Pythagorean theorem. So if I'm going to call that x, you could say x squared plus 7 squared equals 25 squared. I think I got, if I remember right, does it turn out to be exactly 24?
Yep.
Okay. Alright, so I have x squared plus 49 equals 625. X squared equals, what's that, 576? So x is 24. Did I do my math right? Yeah? Okay. Alright, so sine of theta would be opposite of hypotenuse, 24 over 25. Cosine of theta would be adjacent over hypotenuse, so 7 over 25, and tangent would be 24 over 7. And then we could just reciprocate all of these. All right, questions on that? All right, so what if I told you that the cosine of theta equals 3 over 10, and I want you to find the tangent of theta. Okay, so we need to draw our triangle. If the cosine of theta is 3 over 10, that means that the adjacent over the opposite would be 3 over 10. There's my theta.
So then the opposite getting 9.
Would this be 9?
9, yeah.
Well, we'd have to use the Pythagorean theorem, so I'll call it y. So it'd be 3 squared plus y squared equals 10 squared. So y squared equals 100 minus 9, so 91. So y would be the square root of 91.
Okay. In my mind, for whatever reason, I thought 81 plus 9 was 100.
So who can tell me what the tangent of theta is? I know Ben could. What would he get?
3.18.
What'd you get?
3.18.
3.18?
Yeah.
So what is it as a ratio? What over what?
It's irrelevant.
If I have my triangle drawn up there, what's the tangent of theta?
It'd be the square root of 91 over.
Very good. Square root of 91 over 3, and that's the exact answers. Tangent of theta equals the square root of 91 over 3. All right, another example. Let's say I have a right triangle. Let's say that this is 8, this is 5, this is theta, and I want you to find theta. Okay, we're finding the angle theta. Well, we can still generate an equation. Think about what you're going to use. Sine, cosine, tangent. You probably wouldn't use cosecant, secant, or cotangent. So between sine, cosine, and tangent, what sides are we dealing with here relative to theta? Okay, we have a hypotenuse. And what about 5? Is that opposite or adjacent? That is opposite. So which of those trig functions is opposite in hypotenuse? That'd be sine. So sine of the angle is opposite over hypotenuse. So sine of theta is 5 over 8. So that's where you should start. We are solving for theta. Right now we have the sine of theta. So we need to undo sine. So to undo sine, anybody know? What is it?
Inverse.
It's the inverse sine. Some books call it arc sine. It's the inverse sine. It is on your calculator. You do the inverse sine. It's second sine on your calculator. We're going to do that of both sides. So the inverse sine of sine is just theta. And now we want to find the inverse sine of 5 over 8. And I want you to type it into your calculator right now because there's going to be 2 different answers that we get. Keep recording. Okay, so a lot of people got theta is 0.675. Connor, what'd you get?
I got 38.
Yeah.
Exactly 38?
Oh, 38 and some change.
38 and some change?
0.68.
Okay, so which one is right?
Probably 38. Yeah, I don't think, like, point
No,
six
it's
degrees.
0.65.
0.65 degrees is
Should we have our calculator in radian or degree?
Good question.
This class.
Yeah,
the,
so
oh, I don't think I swapped my.
Ben just asked, should we be in degrees or radians? Your calculator, these calculators are in degrees. These calculators are in radians. So in this problem, hopefully the question in the book or on a test or quiz would be find theta in degrees, then we'd have our answer. You probably wouldn't have it in radians for this. So 38.7 degrees. If you're looking for degrees and you get a decimal like that, go to mode on your calculator, change it to degree. Or you could just take your answer and multiply by 180 over pi, and you should get the right answer. That'll change your radians to degrees. Okay, anytime that you're looking for an angle, you are going to have to do an inverse trig function. It might be sine, cosine, or tangent, but it will be an inverse function. Okay, so if I had, last one before we move on to special right triangles. So let's say I've got this, and I've got, let's say that's 4, and this is 5. I might ask you to solve that triangle. That means find everything about the triangle, the sides and the angles. So if that's 4, the first thing I would do is find out what this side is. So x squared plus 4 squared equals 5 squared. So x equals 3. Then we can find, well, we know that angle is 90. We could find either of these two angles. I might do tangent of theta equals opposite over adjacent 3/4. So we could find the inverse tangent of 3/4. Can somebody do that in degrees, please? 36.86. So how big is, let's say it's 37. How big is this one right here?
Well, it's gotta be the difference.
53, good mental math. What do we call these two angles if they add to be 90 degrees?
Complementary.
Complementary, very good. Yep. So they have to be 90, add to be 90 because there's 180 degrees in all three angles of a triangle. All right, questions on all that? That's just that's like half of the lesson. Yep.
Yeah, I just want to make sure. So, on any work that we do doing this, will we always just round up to the nearest degree? Or
No, I was just rounding up just so we could do some mental math here. But
Okay.
if that was 36.9, I would write 36.9.
Got it.
Very good question.
Thank you.
All right. So the second part of the lesson today is special right triangles. You should have done those in geometry. I don't know how much time you spent on them in geometry. I never know what in the last couple of years we've done. But special right triangles. There are two types of special right triangles. The first type is 30, 60, 90. Okay, so the reason we're doing special right triangles, everything up, all these other examples, we needed a calculator. We don't know what the inverse sine, it's not very focused. We don't know what the inverse sine of 5/8 is. We don't know what the square root of 9, the tangent of theta. A lot of the problems you'll see in the future in this class, certainly in future classes, is they'll do problems so that they're special right triangles, so you don't need a calculator. Your test in here for chapter 5, you will not be given your graphing calculators. You will get scientific calculators. The only calculators you will get for the test in here will be the really dumb ones. Let's see if I have a really dumb one.
Oh, like the tiny ones, Mr. Gutierrez?
Yeah, like literally can add and subtract if that helps you. Okay, so the special right triangles will enable us to figure out what the cosine of 30 degrees is. We don't know what the cosine of 30 degrees is, but we will in about 5 minutes. All right. So 30, 60, 90, here's the pattern. If we have a 30-degree angle right here, across from 30, I'll just give you a couple examples first, then I'll give you the general term. So that's 30. Let's say this is 5. We know that that is the smallest side because it's across from the smallest angle. If that's 30, that's 90, that's 60. Or I say 60 and I write 90. Okay, once we know the opposite side from 30, that's the smallest side, we can double it to get the hypotenuse. And we can also use this to find the other leg of the triangle by just multiplying by the square root of 3. So those are the sides of that one. Okay, another example. Let's say it's across, there's 30, that means this is 60. Let's say the hypotenuse is 8. How long is the side opposite 30 then? 4, very good. It's always half of the hypotenuse. And we can use that to find the other one by multiplying by the square root of 3. Okay, so generally if I wanted to write it in terms of x, let's say this is 60. That means this is 30. If this one is x, the hypotenuse can be 2x, and this would be x square root of 3. Okay, so that's kind of the general pattern. Sometimes you'll be given the hypotenuse, sometimes it'll give me this. It's easiest once you have that short side, you can find the other two. Okay, knowing all of that, it's all about being as efficient and lazy as possible. We want the easiest, simplest 30, 60, 90 triangle we can get. So I will say this is 1, which makes that at 2, and then this one would be the square root of 3. This is the triangle version that we're going to use almost always. Okay, 30, 60, 90, just remember across from 30 is 1, hypotenuse is 2, and across from 60 is square root of 3. So let's go back to our question. What is the cosine of 30 degrees? Let's look at our triangle. What's the cosine of 30 degrees?
Square root of 3 over 2.
Adjacent over hypotenuse. Cosine of 30 degrees is the square root of 3 over 2. What if I use this triangle right here? Cosine of 30 degrees is 4 square root of 3 over 8, which turns out to be square root of 3 over 2. Might as well make it so that we don't even have to simplify it. We'll choose the simplest version so there's no simplifying afterwards. Okay? Everybody see if you can tell me what the tangent of 60 is. Don't say it out loud. What's the tangent of 60? You can look at my red triangle. The tangent of 60. Good. Anybody have an answer?
3 over 1.
Square root of 3 over 1, or just the square root of 3. Very good. Square root of 3. Wanted to figure out what the tangent of pi over 3 is. We could change pi over 3 to be 60 degrees. And then we would be able to do a lot of the radian work just by changing it back into degrees and drawing our triangles and figuring it out. Okay, all of that is those are all 30, 60, 90 triangles. All right, the other type of special right triangle is 45, 45, 90. You could actually argue this is a little bit easier. So we have a 45, and a 90 degree angle. if this is 6, this is 6. These are always going to be the same. Because if you're going up 45 degrees, you're going to go over and up the same amount. You're going up 45 degrees. And this is 6 square root of 2. It is always times the square root of 2. So if this is 2, and I know these are the same, that makes it a 45, 45, 90 triangle if those are the same. So then this would be 2, and this would be 2 square root of 2. What if my hypotenuse was 7 square root of 2? What are both my legs? They're both 7. Good. What if my hypotenuse is 8? What are both my legs? That's a tougher problem. How did I know that I went from 7 square root of 2 to 7? What did you do? What do we have to divide by? To go from 7 square root of 2 to 7. We had to divide by the square root of 2. So here we actually have to divide by the square root of 2, just like we do on any other 45, 45, 90. So 8 divided by the square root of 2 actually requires a little bit of rationalizing the denominator. So I get 4 square root of 2. These would both be 4 square root of 2. Okay, so what is the, I'll make the easiest one. I'll do it in red. The easiest 45, 45, 90 degree triangle is 1, 1, square root of 2. That's the one you're going to use almost always. So what is the cosecant of 45 degrees? See if you can figure that out. All right, so cosecant is the hypotenuse over opposite, so it's square root of 2 over 1, or just the square root of 2. Okay? Questions on any of this stuff? This should be fun for you. Solving the triangles, using Sohcahtoa, it's not too bad.